Hello, hello. Good morning, good afternoon, good evening, everyone. Welcome on Learn Grasshopper live session. We are back after vacation. I know that still we have August, but most of the engineers are coming back from holidays. And we have two amazing guests from Switzerland. We have Gelareh and Hamed. Hello, can you hear me?
Hello, yes, we hear you very well.
Hello.
Perfect. Perfect. We have already some people already on the YouTube, so please just write a comment if you can hear us and see my screen. So we will start just in 60 seconds. And as always, we are live on 3 platforms. We are live on Facebook, LinkedIn, and YouTube. And I will really appreciate if you can just share this event with others engineers, give a like so we can reach more people. So we will start in just 20 seconds and I will check everything on the live. Just let me know again if you can hear us well, so we will start shortly. Hello, we have Alexander. So we have some people live, so that's good that we are not going to speak just to ourselves. And today's presentation will be about 1.5 hours. It depends about your questions. Recordings will be available, so we are recording all the session. So you can go to learngrasshopper.com/bridge-dlubal, scan the code. So we are going to share the recording, and also Gelareh and Hamed are so kind that they prepared some Grasshopper files for to set up. So I'm really curious. I haven't checked this out, so but it looks really great. So you can test it out, Grasshopper files at your own. And as always, I'm doing this webinar session for you. So if you have any questions, just write in the comments. We have 2 computational designers here as my guests, so they will be happy to answer all of your questions. We have more people. We have Mateusz, we have Andrew from Australia. Sound is perfect, so good to hear that. So today we are going to present a beautiful bridge. It's called La Pendenta. It's called, how do you pronounce it? La Pendenta?
La Pendenta. Yeah.
La Pendenta, yeah. So it's a beautiful bridge in the Switzerland Alps, and today we have 2 computational designers that's going to share great work, how they connected Dlubal with Grasshopper, and how actually Grasshopper helped them to design this bridge. For those who are seeing me for the first time, my name is Krzysztof Wojsław. You can call me Chris. I'm a computational designer as well. Now I'm 100% focused on teaching programming for engineers, so they can automate their work and have actually fun doing automation. In addition to my learning platform, I'm also a guest on the academic lecturer at the Norwegian University, where we already implement Grasshopper and teaching students Python, C# and Grasshopper. But to today's topic, today my 2 guests, as I said, from Switzerland, Gelareh and Hamed. Hello, can you hear me well?
Yeah, we hear you very well. I hope you can also hear us well.
Yeah, we can. I can hear you. Where are you based in Switzerland?
We are in Bern, and now we are in Trubschachen, which is close to Bern.
Perfect. And both of you are working for the Jakob Rope System, right? Is a Swiss company, or is it a worldwide company?
The head office is located in Switzerland, but it has also branches worldwide.
Perfect. We have lots of people from different places of the world, so that's great. We have Fernando from Mexico, we have Andrew from Australia, Solenia, nice to meet you. Okay, let's jump to your presentation so you can present yourself and the company. So yeah, let's jump to your presentation. So yeah, the stage is yours. So maybe you can introduce company to all the Grasshopper users.
Thank you so much, Chris. First of all, I would like to say that today we are going to give an overview of the interface between Dlubal and Grasshopper, which includes modeling the geometry in Grasshopper and assigning the required elements to the generated geometry, like defining sections, materials, loads, and then exporting it to Dlubal, and also taking the results back to Grasshopper to make this loop complete. And then Hamed will provide you a live tutorial to see how to do it, and I will walk through the bridge script to show how it's done. So about the company that we work in, as you mentioned, it's called Jakob Rope, and it's located in a beautiful area close to Bern. And the manufacturing company is located in Saigon in Vietnam. And Jakob Rope's expertise is in manufacturing ropes and webnet. About myself, I got my bachelor's degree in architecture from Iran, and then I got my master's degree in iTech from University of Stuttgart in Germany. I joined Jakob since 2022, and my responsibilities now include doing computational design and developing parametric workflows for the projects that it really adds value. And also recently, I have been focusing on doing life cycle assessment and doing environmental product declarations to get certificates for Jakob's products. We work on different projects. So we mainly develop parametric workflows for different projects. With this parametric workflow, we can automatically change the geometry to meet the structural needs and also to meet customers' wishes. And also, this workflow helps us to create super detailed models very fast that can change according to any upcoming changes. So it has really made our work more efficient. And when I say developing the workflow, it's not just about developing the workflow for the geometry itself. Also, at the earlier stage of design, it can help us, for example, for locating the appropriate position of the structure. For example, in this example, there was a question of, okay, we have this length and this span, where we should locate it so that for example, the wind cables, the foundations have the least distance from the topography. So in these situations and at the earliest stage of design, it can also help to make your work better and more efficient.
Also, it's I would like to just add one more thing to this previous slide. That is really cool that you involved Grasshopper so early on the early stage. So it's not just for the final design, but even on the finding the best way to go with the bridge. Have you used any software to optimize that the position of the bridge? Because I saw this colorful lines. If you can explain, what does it mean, this colorful lines on the screen?
For this one, we didn't use any optimization process. Actually, it was like a simple calculation to see, okay, we have this distance of the bridge, the length of the bridge, we knew what it should be, and we knew in which elevation we should put the structure. But as you can see, when I play it, there is a wide range that you can, sorry. There's a wide range of options that you can decide to put the bridge. So we took the distances from the lower points of our wind cables, which were the position of abutments and the foundations, to minimize the distance. So we had a range of numbers that from those we could select which one makes the best position for this one. So this range is actually showing as it's getting greener. Here you need less, for example, excavation to put the cables and locate the abutment.
Really great, and it's like, as you said, it's not necessary to use this complex optimization. You can just make it simple, and for sure it works great. Okay, thank you.
Of course.
Hello everyone, I'm Ahmed. I also got my bachelor degree in architecture from Iran, and later I studied ITech at the University of Stuttgart. I joined Jakob since 2023, and my work mainly focused on developing a parametric tool and automation in design and fabrication process. I also developed tools for repetitive and time-consuming processes for in-house use to make the task more efficient. Okay. Here in this project, we also have developed a workflow that uses the webnet as an active structural element. This workflow enables us to position the bridge in any given topography and generate a system lines, structural analysis, and we can also get a bill of quantity, production plan, or any other documented needed instantly. And to demonstrate this workflow, it was used in a design at this suspended bridge in Giswil, Switzerland.
Yeah, and I have to mention this Friday we are going for the opening of this bridge to see it in person also. Now I will explain deeper about La Pendenta, the bridge in Disentis, which was completed in 2024. La Pendenta has a span of 270 meters, and with the height differences between the two abutments about 14 meters, and the stack in the middle is 8 meters, and the total weight of the structure is about 44 tons. Because it's really a beautiful bridge, and we visited it in winter, I would like to show a video of the bridge so that you can get a better view of it.
Yeah, the surroundings around is just amazing. So it's so beautiful to design bridges in this area. So what software have you been using? So you said Grasshopper Dlubal for calculation, and what else?
We also are using Inventor for detailed design.
Yeah, in the company, people also use Inventor for detailing.
And we can see on the screen like preloading, so tested with the calculations. So for those who never seen bridge design, so in most cases you have to test it out. The bridge here, they've been using water tanks to test if the response of the bridge is similar with the calculation. And this looks amazing with these waterfalls going from the bridge.
I will move to next slide. Okay, as I told, the bridge was completed in 2024. In 16th of November was the opening. And this bridge has been nominated for Building Award in the category of infrastructure and environment. And also an article has been published in Rhino 3D Zine and in Dlubal. They have reference to this project as their reference project. And also, because this bridge was finished close to Christmas, we also created a Christmas card, which I think can show the project is, of course, unique, and it's like a good advertisement and marketing for the company. I like to mention one of the interesting challenges for this bridge, which is designing the plates. It had to meet two criteria. One of them was these plates should have had the consistent area of 700 square centimeter, and they should be aligned with the direction of coupling cables and also the wind cables. So, and I have to say that these plates are for O's, so that they don't hit the coupling and wind cables. And this is how we approached it. We explored a wide range of design options. These options had different fillet sizes and they had different directions, but we chose the ones that they could meet this criteria of consistent area, and also they were along the cables. Because as you can see, each cable at the intersection has its own different angles.
So it was every single plate was different, right? Every single. It was no any scenario that plates were similar.
No, just because the bridge is mirrored. Of course, the ones which are mirrored, they are similar.
Mm-hmm.
And to provide the work, to tell about the workflow of this project, the model is generated using Rhino and Grasshopper, and structural features are assigned to the geometry, like the section, the material. Also, this can also be defined in Dlubal, of course. Then the generated model is taken to Dlubal software. It's analyzed, and then the optimized result is back to Grasshopper. And also, as I mentioned, Rhino and Grasshopper helps to do super and high-level details in Rhino. So the basic geometry was used by by the steel supplier for creating 3D models that are applicable for construction.
Mm-hmm.
And now I will hand over to Ahmed to open the script.
Yeah. So now we will go to live presentation. So we will see how the Grasshopper in action. So hope nothing will crash.
I also hope to. But so I wanted to start with first I will start with a very simple example to show how we can define the geometry itself and then assign the structural property to our geometry, how we can export these structure to the Dlubal, run the simulation, and bring the result back again to the Grasshopper. So we'll have the full loop in Grasshopper if in case you wanna run any optimization processes or any other uses. After that, Gelareh will show you the Grasshopper file for the for the actual bridge, because that one is like a little bit big. So we just start learning by having a simple truss. But before that, I also wanna mention that we are able to import a structure with all the structural property imported to the Grasshopper. So we can simply use the RFEM 6 import component and run these components. Of course, I also have the model opened in my RFEM, so they can make a connection. It uses a web server to send and receive the data between these two softwares, so as a bridge. It's also, let me see, our model is a little bit big, so it takes time to import all
and the link between Dlubal and Grasshopper is for free, available for free?
Yes. In Dlubal 6 it comes with the Dlubal licenses. In RFEM 5 it was a separate license.
Okay. So actually, you don't have to model everything from scratch. You can also get import to Grasshopper already modeled manually in Dlubal, and then import it to Grasshopper, and then make all the modifications, right?
Exactly. I will mention it later in Grasshopper file also, but for some options, like for example, design situation or load cases, we are not changing every time we want to run the simulation. So we can just define these property once, save it as a template, and you reuse it again. So we can assign this property to our, for example, load members again and again and again, and just define it once in Dlubal.
And everything is modeled as a beam elements here.
We have also some cables, so and they are cables.
Yeah, so basically cables, and beams, beam model.
I can show you the model a bit while it takes time to import. And here you can also on the bottom see it's talking to the Grasshopper client.
So maybe you can also tell a little bit what elements been created with Grasshopper and what's been created with just Dlubal.
Actually, in this model, everything is modeled in Grasshopper. It's done finally. So everything is created in Grasshopper geometrically, but for the design situation, load cases, load combination, these properties that they were defined in Dlubal. But now we imported our model, but it's like a data package, so we cannot do anything with this one. We need to somehow deconstruct it, split it down to the different elements. So we can use the component called data component, and for example, for the material, we can use the material component from the Grasshopper, but here we should change the mood of the component from the assembly to extract. So here we can see the name of the material we used in our previous model. We can also see the index of those material and any other options they have. Or for example, I can also import the members. So we can see the cross section. Of course, we also need, so these are the index of the cross section we defined before, but we can see them here, and these are the Grasshopper line we have.
So actually, you can extract all the information about materials, cross-sections from the active window. So we have to have the window active from Dlubal, and the link is just created as you just dropped one component, and then you can just extract one by one.
Exactly, yes. And if you just need to import a specific property, or if you just need the material, and your Dlubal model is huge as this one we have, and you don't want to wait several minutes to import or export the whole model, you can here filter your information. So for example, I can make this one true, so it will only import, I shouldn't have imported it, but only import the material for myself. From the Dlubal. I hope, yes.
So you can limit. So you can limit actually what you can make select and filter it out.
Exactly. Yes. So let's start with our simple truss. I can start with the simple horizontal line, like I can give it a length, for instance, 10 meter. I can move this line in Z direction, I don't know, 1.5 something in a Z direction to create the upper part of my my truss. I can also divide these two lines to be able to draw the diagonal and vertical elements. So now, first of all, I need to draw my horizontal lines in a bridge. I prefer to, although I have a single line for this horizontal line, but I prefer to make it like a polyline, so segmented. Sometimes in this intersection point, Dlubal automatically detect this intersection point and add a point on it, but sometimes it miss this intersection point, and structurally our structure is not connected. So it's better to, from scratch, we create it as a separated segmented line. So I can create a polyline out of it. I can also flip my data to be able to have the vertical ones. For the diagonal ones, I can remove these points in top and bottom one after each other. So here I can just keep this one, but I also need. Okay, so for the top line, for the bottom line, I will keep this, and for the top line, I can change the pattern. So yes, and we can merge these two lists together and create the diagonal lines. We also, it's much better advisable if we explode these polylines to the segments. So we can explode them and also flatten all the output geometry. Okay, so now we have everything we want. We also need to create our like a structural element with different cross section as a separate container. So I prefer to use telepathy. It helps me a lot to organize the data here. I can, for example,
I can also recommend Telepathy. It's a really great plugin to define the OR variables and do not make that much mess on the script.
Exactly, and you will see in a model like the decent bridge model is a huge model, and you cannot really keep track of data without having the tool like this. So I will add this L for having my lines, and then the name of the lines after that. So horizontal lines, vertical lines, and diagonals. So now I have all the geometry I needed. I also need the 2 point for my support points.
For the supports.
Create them and add them here. Okay. Now we can start creating the model or all the property we need for the Dlubal to work properly. So I can create a new file, name it test, for instance. Okay, so in data navigator parts, we can see what type of property we have in our Dlubal model, and we can use these lists also as like a checklist to define everything based on this. So you'll start with the material. We need for each object in Dlubal, we need a specific index. So I can give this index manually, as we only have probably one material. We also need a name of the material, and this name should be matched exactly with the material we have in a Dlubal library. So we have 2 ways to get this exact name from the Dlubal. Either we can create the new material and search the name of the cross-section from this list, or we also can go to the CAD beam tab and open conversation table. Here we are also able to search for the material. But just one point I forgot to tell, before doing that, we have to go to program option. We need to turn on some option first. For communicating between Grasshopper and Dlubal, we have to turn on or check these components, this checklist thingy, web server, to be able to bridge the data between two software. And also here, we can check it to be able to have a full name of cross section and our material. Otherwise, it just writes, for example, IPE 300 and not the code names. So, for instance, we'll just write the S255 and not the code. And in a library, they have several codes, so it will take the first the material with the S355. So it's better to have a full name here.
And just one more question. And the connection will be established. You have to open Dlubal as a first and then Rhino, or it doesn't matter?
It doesn't matter, but when we want to exchange data between these two software, we have to have Dlubal open.
Open, okay.
At the end of these definition, before running the export component, I have to have the Dlubal open. So I already copied the name of the material. I can paste it here. make some more space for all the rest. Okay, so I have my material defined here. I have to go to for the next one. I have to define my cross section. This is the first one. I have to give it the index, and it's not like a Grasshopper. So here in Dlubal, we are starting from 1, 0. It's not important. And for the name, I can just give it a cross section, any cross section.
It can be hard for Grasshopper users to start counting from 1. If your whole life been, if your whole life been counting from 0, now you have to change again.
And again, to keep the data structure also in Dlubal section, we name these data Dlubal.material.
Mm-hmm.
And I can change this name to section 1. So I have this cross section created. Of course, we have all the options as we have in a Dlubal software. So these are optional property. If you want to define it, we can define it here, or otherwise just take the default value from the Dlubal. For the next one, we can also change these. We can use the different cross section for the other type of members that we have, and I can give it another name. So now we are defining, we have defined the material, the cross section. We are ready to define our first member. We need a Grasshopper line, so I can take this receiver just by right-clicking on this telepathy on a key. I have all the lines here. So I need my horizontal line for these. I need to give each line in my cross a specific index, so I can get the length of this list.
It's not given automatically. You have to always give the.
Well, if we only have one member component, then it will get automatically. But if you have several member component, and then later on we want to use these members to define also our load members, and so it's much better to define by ourselves, have control
and have control on everything. Yeah.
So you can use a series, and the important point is to start from 1. So we have our first lines. We also need the cross section. Sorry. So Dlubal cross section 1. And the type of material we can also define. And we can define this by just connecting a value list to this component here.
Oh, nice. So it's automatically finding information from Dlubal.
It will bring all the options that we have in Dlubal here. And set it as a cross. Okay. It for the first one. For the second one, I can use the horizontal, the vertical elements. And for instance, I can also bring the diagonal ones. I can merge these two members together. And again, we need a list. So how many lines do we have? And also we need a last index we use in previous component, so we can get the
so the numbers are not overlapping.
So we can get the last item that we used here. We can +1 because we're gonna start from one more, and in this component we can start it from the next index. And also, so for this one, I want to use difference cross section, so I can just change my cross section to 2. So I will take the cross section from second cross section component, and now we can create our support. So again, I need my lines.
Or just the points. What do you need? Just the points for support?
Yeah, exactly. These 2 points that I used. So I can, because I only have one component for defining the support, I can define it by myself, or it will automatically define it by itself. But I have to define the type of the support. So if it's rigid, I can use infinite, and if it's 0 or any number between these two, if you have any specific number for it. So you can also define the support. I forgot to also create the telepathy container for my members. One and member 2 and also okay. So now we are defining our we have defined our supports, we have defined our members. We can move forward and define our design situation, because so I want to export everything from Grasshopper, and I'm going to run it also from Grasshopper, so I have to define everything here by myself. But as I said, we can just define these property in Dlubal and just give it the index, and it also works perfectly. So again, index and a value list for the designer's type. And we also have to export it. We can give it a name like this. Okay. What else? Now I can define my load cases.
So the loads as a dead load or other loads are, you can also define in Grasshopper, like a points or lines, or how to get the dead loads of the weight of the elements.
Yeah. Of course, this is not my first expertise. I just asked this information from mainly the structural engineers. But so we can use the action category. We need the index, and we also need a name. should be enough. And for the static analysis, we can also take it from here.
In the meantime, we got also a question if users can get this example, the Grasshopper file example.
Sure.
Perfect. So we are going to share with the tomorrow email. So if you are going to register, so you're going to get this example as well, so you can test it out by yourself and do export from Grasshopper to Dlubal this truss.
Okay. Also, we need load combination. We need the design situation components here. So for the load combination, for the design situation component, we also need the index. We can also take this one from here. Design situation, and I can connect the structural analysis, the thing that we created before to also load combination. For the item, we can just give it a simple factor 1 and then simple index. It should be enough, and also index for our load combination.
It's also great that the terminology, the names are actually the same that are for Dlubal. So for Dlubal users, it's not kind of black magic, all the names, and they are similar, the same. And the icons, I think, are quite similar, right? All the icons. Yeah. So maybe for not Dlubal users can be for the first time seeing too many components, but for those who seen Dlubal before and used it, that this should be much easier to understand.
Okay, so I think we have defined everything that we want, and now we are ready to export it in RFEM and see if we can run the simulation also. So I can just bring this component, RFEM6 export component. I have to connect everything I have created before to these components. So now that's the time to use the power of this telepathy. So I can say e dot star, and it will connect all the container related to Dlubal for me.
I like it. I like it. It's really nice, very nice presentation of the telepathy. So for those who never used it, so you, Hamed, just confirmed that it's a great tool to use it. It's not like an input and run as a Boolean.
Also, we have some option to modify here. So as a default, my Z direction is flipped compared to the Rhinos. If I want, I can also change it to true. I can also run these components and see if I can successfully export model.
Nice.
And so now we have exported the model with all the structural property, but we wanna Design situation type. I should have.
No worries, but we saw that it was exported. Maybe the numbers, it's the same, like it's just a one.
No, I connect this component instead of one below. So instead of static analysis,
By the way, in the meantime, we had a question. What is the full name of the plugin that connects the RFEM with Grasshopper? What is it called? It's just a Grasshopper Dlubal, or?
I guess it's Dlubal itself. It's the name of, so it will install by installing the.
It's a Dlubal plugin. Yeah, it's called just Dlubal plugin. Perfect, thanks. So what we are changing, just a type of design situation?
Design situation type. Let's see.
And it's every time sending to Dlubal. That's why. So I think that users also will see the computational designer work that is not always working. Sometimes it's changing colors to red, and you have to find it out. But luckily, Grasshopper gives hints what can be wrong.
Okay, because we also have to define. Oh, let me. I think I found what I missed. So here we have to define our design situation type also, and I forgot to define it.
So it looks like you can every single option and situation that is Dlubal, you can also access from Grasshopper. It looks like you can extract all every single information, design case, design situation type, and action type category. That looks good. That there is not that much limitation. So it's supposed to be like a permanent, or what you are looking for?
If it's working, then.
So you cannot choose from the list, or?
Yeah, it's a little bit slow. So maybe this time I can try my luck.
The most importantly that we got this exported, and voila, perfect. So you showed Hamed your amazing skills with creating this script, which is really impressive, creating that script so fast. And now you also showed how fast you fix bugs. So well done.
Thanks. So now we have exported the geometry and the property to Dlubal. We want to run the simulation from the Grasshopper, and we can doing this by using this component called calculation component. So we can run this either with the toggle, or also we will get an Boolean from the output of this component when this component could successfully export the model. So you can see, like, get the confirmation when it's does the job completely. Then you can run the simulation. You can feed this new component with the export component. Then here in Dlubal, it will run the calculation. You can see it also here on bottom. And we will also get another, oops. Oh.
So it's pointing in some of the nodes that they are too close.
So the problem is I exported this model several times. So every time I hit this export button, it exported the new model, and they are overlapping with each other. And to fix that, we have another option here, override.
All right.
So we can erase everything we uploaded before.
So before it was like finding lots of points next to each other, and yeah,
a lot of duplicated structural elements.
Yeah, you are sharing lots of good tips for users who are starting with Grasshopper and Dlubal, so they don't have to find it by themselves. And finding, like for a beginner user, finding this kind of error, it will take like maybe 1 day, and just for experienced user as you, it's like, okay, 1 second, and okay, it's too many exported models. So now we have 63 elements, so that looks much better.
We can create a new model.
So it's about just to create a new model, and the link will be created again. That's also really nice that it's so fast that you can just switch from one script to another to create it.
Also, as you can see here, I have several models opened in my Dlubal, and here it just takes the latest the file I have opened, but if I want to communicate with a specific model in my Dlubal, I can also specify the name of the model somewhere here. Name of the model is here, but name of the model Dlubal here. So I can also choose which model I want to export my file to.
So if you don't have name, so it will take this one which is currently open, right?
Yes. Yeah.
And how often are you using Grasshopper at your work? Is it like your daily software that you are using? It looks like.
Yes, that's our daily job.
Okay, and how many Grasshopper users do you have at your company? You, Gelareh, and you, Hamed, and any other users?
Yes.
People can have access to Grasshopper, obviously, but they don't use as often as we use.
Yeah.
But there is more and more people like to learn it, I think, because they see how it makes the process faster.
Yeah. So you are from this hard work, and if someone faces the challenges that they don't want to model this manually, so they come to you, and you make all this magic, right?
Yeah, exactly. And also have to add about Thomas that he has been teaching Grasshopper from Iran maybe since 10 years ago. So now he's not teaching, but yeah, he also has the experience of teaching.
That's good. Perfect. Nice to hear.
Now I have to say I have to cheat a little bit because probably I did something wrong during the process and I cannot troubleshoot super fast during the live.
No worries. You did everything perfectly. It's just Grasshopper doing something wrong.
These are specific dates. So touch to showing the next step. I use the sample file. I used it before. Yeah. So you can export the model, run the calculation, and I will also share this file with the user so they can also see and then compare it with the live demo I had. But after we run the calculation successfully, we can also use these components to export the results somewhere in our computer. So we have to say where do we want to save this information, give it a name, give it a format, and then it will save everything for me. Of course, we have to
maybe you have to create the folder.
I have to create it first.
Okay.
And
And what is this component? What is it called? How is it called?
This component called export result, I guess. On my first try, it didn't work properly because I had a different model name defined here, but now I have my results here. Yes. You want to say something?
So everything is in the Excel like CSV file with all the informations about members, nodes.
Exactly. For each node, we have the formation in different angle, in different orientation, X, Y, Z, and monument. And we can also read these Grasshopper file, CSV file in Grasshopper. So we can take the path. Of course, I changed the path so I can manually again navigate it to the new folder I just created, and then open this CSV file. I can parse data in a way that separate the header and just extract the formation that I needed, like here. And if we want, we can, by using this result here, we can run the, so we have a complete loop. We created geometry, we exported, we run the simulation, we have a result back. We can put it in an optimization algorithm and run it through the algorithm process. I guess it's all from my side. So I will hand it over to the Gelareh for the Dlubal.
Like we can also maybe just say one thing that one of the biggest benefits is that if you are going to change one of the inputs in this truss, so everything will be updated and you don't have to build it from scratch. So because sometimes our people are seeing this, like saying, okay, I can make the same in Dlubal. And it's true, you can do actually all the same, but the thing is when you're going to make a change, so you can update with just one click. Okay, but let's go to a more advanced example.
Yes, Here is the bridge model, and to give an overview of the script, we have the geometry section. We have the RFEM model data that we have to assign to our geometries. We have the member load, load cases, load combination. I have a section for RFEM export and also for Rhino export, which is a good feature that is added to Rhino 8 so that you can bake everything with its layers, and each time you don't have to bake one by one and assign the names again starting from the scratch. So this option also is an option added.
Can you just say one more time and what you are? It's okay. So you are taking geometry back again with the correct names, and you can just bake it in Rhino. Okay.
Yes, exactly. To start with, so we have the topography from the customer, and we started simply from a simple line. It's easier because when you have a line that everything is extended from it, so then you can, for example, if you want to orient the whole structure and the topography, for example, to geolocation, we can also use the same line for orientation and everything. From my simple line, I use the catenary line, and this catenary line defines the stack of my bridge, and it's better to use catenary line instead of any other curves or nerves like arches or nerve curves, because then later in Dlubal, when you want to do the form finding, it's going to make a form finding which is closer to this shape, so it's better to start from catenary line. As you can see, I can change the stack of my bridge. I have defined also my wind cables with the same catenary line. And this catenary line has the feature of the length. So with this length, I can again change the length of each line. I can change the rotation of my lines. So basically the point is that you can define as much as parameters you want to define. Also the height of my wind cables. For this bridge, for the segmentation and for defining the distances for the splitting the elements, we had a formula that we have used for this part.
Mm-hmm.
Also, I have some elements which are called A-frames. So to define my A-frames, I started with a simple line, and I oriented it in the distributed appropriate position for the bridge. And what we usually do is that we usually use blocks for super detailed models. For example, I have a sample here.
Mm-hmm.
I hope it's visible. So, for example, the cross-section is detailed, and we can change it very fast and easily because I had already defined a block model in my Rhino, and I had assigned all the points that I needed later for connecting my curves. So, as you see, I have the points. And this block is oriented along my bridge, and so if these are the segmentations, later I can use the same points I had defined in my block so that I can create my other curves. And in this way, everything will change automatically. So when you change your block, automatically your cables that you need later, they will also change. So this is a good feature also added.
And you have to think about it beforehand. This is something really important, that before you design, you have to think about it. So this is great. One more question from Carl Johan about the site topography data of the terrain. How you receive it? I can see some mesh of the terrain. Have you received it from some others, or it was photographed?
Sometimes we receive the mesh itself, but sometimes maybe there are only curves that we generate mesh from the curves that they have given us.
The contour line.
Yeah, the contour line.
Yeah.
Also, other curves that I have, I can, for example, change number of my cross beams. I also have some small connection details for my handrail cables. I can also change them. So you can define as much as parameters you need. And as Mohamed mentioned, here, which is in a bigger model, using telepathy is the best option, I think, for managing your workflow. Whatever geometry I needed, I have here. So because they are the lines that I need later, the naming is like L dot coupling cable, L dot main cable, or L dot A frame. So here, now that I have all the geometry I need, we have defined our RFEM model data. As Mohamed explained, first it starts with defining the material, each of them with its own unique number, and the name for the materials that we need. Also, for each of them, we have their defined the telepathy standard, because later, again, we need these outputs for defining our section. So now, again, I got my material for section 1 from material number 1, and it also continues like it for the rest. So then we have defined all the sections. For each of them, again, we have the remote sender. And if you notice here, because I will later need them to export to my Dlubal export component, I have defined them as dl.material1 for 5, and also in the sections, it starts the naming with dl.section1, 2, 3. And it continues. After we have defined the materials and sections, it's time to define the members. So whatever member I needed to have the same section, I have them in one data container. For example, my A-frames lines are in one receiver. My wind cables are in one receiver. And as Mohamed mentioned, we need to assign unique ID to each of them. So now here I have 78 lines for my A-frames. And we got the list length to create a series starting from 1 to 78 to assign it to the number for my member component. And again, for next one, it builds upon the previous one. So we get the last item of the previous series. We add it to 1. I had already 78. I plus it to 1. Now I have 79. And the rest of the list starts from 79, as many as the, and it continues to as many as lines that I have. So this, basically repeating for the whole member components, and for each of them, we have the member sender.
I really like how you organize your script and data. It's really clean. It's not spaghetti monster at all. It's really nice organized. Well done. Well done.
Thank you. And after defining the support section, material, and members, it's time to define the member load and load case. For the member loads, we need load cases. So already before member loads, we have defined load cases. Here we have defined load case for dead load case for form finding, and also load case for snow plus wind with snow. So each of them also, like the previous components, get its own number. They get their own load case, and also I got the member numbers from the members I had defined in the previous section. So maybe if you take a look at closer to the scripts, it will be easier to find out the connections yourself. The load combination is also defined, like the example Hamid showed. And here we have the RFEM export. Which I have, again, flipped the z-axis. I can overwrite. So each time if I change something, it overwrites the previous model. And here is my Rhino export. I got all the lines that I had defined in the previous section. I have defined a layer. I have connected it to a model object, and finally we merge them all. And here is the bake, also to see what it does. It was challenging for me before to bake them one by one, but now here you can have them. You can have everything like the way that you have defined in your workflow, clean and in a good way. And now I can also
just to check if the Dlubal is open, right, with the new.
So that's also important point. If it has has any dialog window open in Dlubal, cannot communicate.
I hope now can communicate.
Okay, so now we are trying to import everything, and we'll see if it will work. By the way, in the meantime, we have some questions, so we can answer if it's okay for you. From Carl Johan, can it handle dynamic load cases such as vibration from pedestrians? Can you set up load cases for vibrations?
We haven't tried. We haven't studied the case, so actually I'm not sure. But so in general, every option we have in the.
I can open you. Sorry.
Yes, we can also add dynamic load to the. Defining the Dlubal and from Grasshopper.
Yeah. Also answering the question. Yeah, there are also seismic loads, so you can define them. So yeah, I think it's you can do it. And also, Carl, you ask about how does Dlubal compare to other code compiled finite element analysis software in terms of Grasshopper integration and flexibility with complex geometry and large assemblies. I can answer that one. So yeah, there are most of the finite element software that are used nowadays has this connection with Grasshopper, and of course some of the connections are better than others. But what I've been testing, like major companies that are doing great job with Grasshopper integration is of course Dlubal. That's as you're presenting today. It's Sophistic. Is FEM Design for sure, is Midas software, and Oasis GSA. It's also doing great job. The rest is still in the development, but most of the softwares, they have the integration, and I can also share the article that I made about the list of Grasshopper integration with structural software. So you can check this out. I made it once. Okay, let's come back, and I can see that we can see our bridge.
Actually, because I have several models open.
Maybe it's too many test names of the files.
Crashed, so.
Yeah.
Joy.
And in the meantime, also, if you have any more questions from the audience, so we will be happy to answer. Because are you using Hamed and Gelareh any other softwares than Dlubal, or you are using also other softwares for finite element analysis?
No, we have tried Karamba also. The problem with Dlubal is this communication takes a little bit long time, so it's a bit hard to run optimization because for each iteration we have to wait for a couple of minutes. But Karamba, because does the calculation within a Grasshopper, it's a little bit faster. So
yeah,
those type of jobs I prefer to work with.
Yeah, I didn't mention Karamba because the question was about like outside Grasshopper and integration. So Karamba is like a native software that works inside Grasshopper for finite element software, and also works great. Do we have some troubles with exporting that one?
Yeah, I wanted to say outside of Grasshopper, the company only uses Dlubal for FEM analyzer.
So, are you trying to with the new component? Try to.
It says it's actively.
Yes, because it's crashed. So now it cannot connect, like make a link by using web server to the Dlubal again. So ideally, I have to close the Rhino and Dlubal and start it again. But yes, now it works. Okay, now we have the bridge here. It's of course flipped. So
it's flipped, yeah. That looks good anyway. So. So you have defined all the, so you can see all the supports and all the cables, all the beams. Great, nice.
Now you can see it corrected.
Because we have assigned it several times.
No, but now it's the direction again, so now it's in a correct orientation.
It looks good.
You can see it.
Perfect. So all the who are seeing so can see in this beauty in the real world. And my question I have also Because this project was done 1 year ago, do you see any chance to reuse this script on the other project? Is there anything that you can maybe parts of the parts of the script, ideally, maybe use the whole script? Is it even possible at your work, or you have to create from scratch?
Yeah, actually, even now that we have a new bridge, I almost use the same workflow that I add to it to change some stuff. If it's super similar, of course, it needs minor changes, but in general, there are some main components and some parts that I always use the same. And yeah, now we are going to have a new bridge, which is about 500 meters.
Yes.
So it will be super similar, and we will use the same script, probably with some changes.
Nice. So it will be the biggest one that you are designed so far, 500 meters?
Actually, we are the computational designers, but with the collaboration of the...
But for you, it will be the longest?
Yes.
Yeah.
Perfect. Is there anything more that you would like to show us?
I think that's all from our side. Thank you so much.
Thank you so much for your invitation.
No, this was really like your skills are showing. Like, can I ask how many years are you working with Grasshopper?
Actually, I worked more than 10 years with the Grasshopper.
Yeah, but for me, it's less years since when I started my master's. So mainly focus from that. Yeah.
Perfect. And you learned already at the university. You made your master in master thesis in Grasshopper, right? With using Grasshopper. Have you been already learning Grasshopper at the university?
Yeah, from the first day we have to use Grasshopper, but at universities it's not like that. They teach you from the scratch and from the basics. So it's better to have some knowledge from YouTube tutorials or any other place that they are producing tutorials. But as you use more and more in projects, I think you will get more experts. And for our thesis, we also used Grasshopper, but it was a combination of different softwares. So Hamed did his thesis in robotics. So some part of it was Grasshopper. Yeah.
Perfect. Thank you very much for your time. I would like to also invite all of the audience here for the next webinar. In 2 weeks, we are going to talk about IFC, how to manage IFC in Rhino and deliver in Revit. So with Mikael and Mauro from MKS DTech from the BIM software, we are going to have a 2 days workshop. So really invite you, for everyone who is working with IFC files and want to change and automate IFC attributes in Rhino and then send it to Revit. This will be really great workshop. For this bridge, you don't have to have you need to deliver IFC or not? Just a production file?
Think you delivered some IFC for all the attachments?
Yeah, of course they are in IFC format, not like the real IFC to have all the attributes assigned.
Yeah.
But yeah, for converting to IFC format, now it's very easy for us.
Yeah. So so in 2 weeks we are going to have workshop how to do it in Rhino, how to change Rhino into BIM machine. Again, thank you very much. It was pleasure to have you here and showing first time Dlubal on our platform. And I hope that more Dlubal engineers were inspired to use Grasshopper and amazing workflow. Thank you very much. I appreciate it.
Bye-bye.
And hope to see you next time. Maybe you are going to present next bridge or maybe another structure.
Sure.
Perfect. Good luck. Bye-bye.